Hi, I'm Maciej, I'm a software engineer, and this video is part of a series that demonstrates the formal assistant tool. In previous parts, you have seen how Mathematica can be used to support some basic software verification activities. You have also seen how some of the work can be automated and encapsulated by a deduction engine. And you have also seen a lot of added value in functions like validate and satisfy that can provide high abstraction by means of rewriting complex verification questions into simpler forms that are then processed by lower levels. So is it possible to automate and raise the abstraction even further? Yes, we can. And this is the role of level 3 in Formal Assistant. And what is wrong with those previous levels anyway? Well, there is nothing wrong, but as you have seen in examples, you have to know what verification questions need to be asked. This assumes that you already have some engineering artifact, like a source code, and you know what kind of possible issues in this artifact you want to address. Like, for example, there is an array access and you want to check whether it is within bounds. Or there is an arithmetic operation and you want to check whether it fits the range of the target type. Or you don't trust pointers, and so on. This requires a lot of manual work, which has to be repeated whenever anything is modified in the code. Some of this work can be automated even if source code is the only starting point. Popular static code analyzers do exactly that. But I believe that formal methods are more effective if they are applied at a higher level of abstraction, because there we can ask not only about source code things like arrays and numbers, but also about design level constructs like state machines, events, data structures and their transformations, and so on. In other words, we can operate at the level of what the program is supposed to do, not just how it shuffles single numbers around. That's why we are talking about modeling now. Many people think that models are about drawings, but this is not really the case. Models are precise descriptions of some engineering aspect of what we try to build. Some notations indeed use drawings, but there are also modeling systems that rely on words, symbols and operators, which makes them more appropriate for parsing and automated processing. Event B is one such method, and some of it was implemented in the Formal Assistant tool. This simple example is a model of a counter that counts from 0 to 10. There are some high-level expectations expressed in the model, like the counter type and range. There is an event called tick that does the actual counting, and so on. This is not a program as you would typically think of it, but a model, and it precisely describes what we expect from the program once it is finally written. And actually we could even generate the code from this model. This model is very simple, but it's enough for the tool to automatically generate multiple verification questions, which are then passed to the functions that you have already seen. The fact that this work can be automated means that we can be more brave in developing and modifying the model, and the whole process can go much faster. Working with the model and verifying it with formal methods is just as comfortable as recompiling the program after adding a new line of code. Now imagine a model, which is one of many examples in the Formal Assistant tool, that automatically generates not few but many hundreds of verification questions. Certainly you wouldn't like to repeat this verification work by hand just because some requirement was changed or added. But with modeling and formal methods, the verification can be automated at the level of abstraction where user requirements can be expressed as well. Event B is currently the only modeling method that was partially implemented in the Formal Assistant tool, but the flexibility and modular nature of this tool mean that it's possible to replace or extend this layer depending on the needs of its users. If this sounds interesting, stay tuned. I'm Maciej, I'm a software engineer. See you next time.